This section introduces additional AWS services that provide AI/ML functionality for common use cases. The AWS services that are described on this slide highlight just a few of the AWS options to use AI/ML to perform specific tasks. You can use many of these services with little ML knowledge and can integrate them into your applications. The resources page in your course provides a link to the AWS AI Services page where you'll find a complete list of AWS AI services with links to go deeper on any of them. Amazon Comprehend is one example of a service that simplifies a specific type of ML problem, specifically natural language processing. Amazon Comprehend can analyze a document or set of documents to gather insights about it. The service uses a pre-trained model that is continuously trained on a large body of text, so you don't need to provide your own training data. Some insights that Amazon Comprehend develops about a document include the following items: a list of entities, such as people, places, and locations that are identified in a document, key phrases that appear in a document. For example, a document about a basketball game might return the names of the teams, the names of the venue, and the final score, the dominant sentiment of a document. Sentiment can be positive, neutral, negative, or mixed. You can also create custom models if needed. The example on the slide illustrates one way that you might use Amazon Comprehend to process data that has been ingested into your pipeline. In this example, customer product reviews have been collected in a data lake. An AWS Glue ETL job gets the review data and calls the Amazon Comprehend API to process each review. The AWS Glue job writes the results of each record to a separate location in the data lake. An AWS Glue crawler runs to discover the output data and adds its metadata to the AWS Glue data catalog. Data analysts can log into Amazon QuickSight and create visualizations of the data that are backed by the Amazon S3 query capabilities in Amazon Athena. The Analyzing and Visualizing Data module talks in greater detail about Athena and QuickSight. Here are a few key points to summarize this section. AWS offers purpose-built services to address common ML processing use cases, such as natural language processing, image recognition, and time series data. You can incorporate these services into the ingestion or processing layers of your pipeline with much less overhead than building your own ML solution. This section summarizes what you've learned and brings the module to a close. This module provided a brief look at machine learning and focused on the ML lifecycle, which guides how data engineers and data scientists collect and process data for ML models. The module took a quick look at general ML concepts and described the activities that are performed in each phase of the ML lifecycle. You learned about framing the ML problem, collecting and pre-processing data, feature engineering, model development, and model deployment. You also looked at the AWS infrastructure services that you can use to implement the ML lifecycle. Finally, you were introduced to a few purpose-built AI/ML services that you can use to solve common use cases without needing a lot of ML knowledge. Here is the sample exam question for this module. A data scientist is working on an ML project that uses supervised learning. They just got access to a dataset with 4,000 records to use to develop their ML model. Which option reflects a best practice for working with the data? What are the key parts of the question? Here are the key words and phrases in the question. The question notes that the data scientist will use a 4,000 record dataset to develop an ML model. The question asks for a best practice. Now let's look at the answer choices. A, remove labels from the dataset so that the model learns on its own. B, split the dataset into a training dataset of 3,200 records and a test set of 800 records. C, split the dataset into a training dataset of 2,000 records and a test set also of 2,000 records. D, use as many records as needed to reach the desired accuracy and remove labels from the remaining data for testing. Based on the keywords that were identified in the question, which answer is correct? We'll pause here a few seconds before discussing the correct answer. If you need more time to consider the answer choices, pause the video. The correct answer is choice B. Choice A, remove labels from the dataset so that the model learns on its own, is incorrect because the question states that this is a supervised learning model. Choice C, split the dataset into a training dataset of 2,000 and a test set of 2,000, is not the best choice because it doesn't use enough of the available data to train the dataset. Choice D, use as many records as needed to reach the desired accuracy and remove labels from the remaining data for testing, is not the best answer because you want to split your data to suit the project and set some data aside for testing as a percentage of the total dataset. Choice B, split the dataset into a training dataset of 3,200 records and a test set of 800 records, is the best answer. This is in line with the best practice of using 70 to 80% of your data for training and the remaining 20 to 30 for testing. That concludes this module. The Content Resources page of your course includes links to additional resources that are related to this module. Thanks for watching.
Welcome to the Analyzing and Visualizing Data module. This module focuses on AWS solutions to analyze and visualize data and factors to consider when you select a solution. The introduction section describes the content of this module. In this module, the focus is on understanding what to consider as you are selecting tools to analyze and visualize your data. The module compares 3 AWS tools and services for this purpose. You will also review a use case to examine the influencing factors and the selected AWS solution. The objectives of this module are presented across multiple sections, each with its own video. The module wraps up with a sample exam question. This section explains the factors to consider when you select analysis and visualization tools. Throughout this course, you learned about the layers of a data pipeline. Raw data makes its way through the stages of the pipeline: ingestion, storage, processing, and analysis and visualization to produce insights about the data. This simplified diagram illustrates where analysis and visualization is in the data pipeline. Although each layer is distinct, how data is analyzed and visualized is tied to how it is stored and processed. Data engineers focus on the infrastructure that the data passes through. This 3-part framework will guide you through the questions that you need to ask and the factors that you should consider when selecting data analysis and visualization tools and services. To build the correct pipeline, it's necessary to fully understand the desired outcomes based on business needs, the characteristics of the data, and who needs access to analyze and visualize data. Keep the end goal and business need in mind as you design the analysis and visualization layer of the data pipeline. Which analyses are needed to develop insights? What insights can be pulled from the data? What visualization would illustrate the insights? Does the customer need to generate a report or interact with a dashboard? The granularity of insight relates to the level of data that one has access to. A finance manager has access to data for their line of business, whereas the chief financial officer has access to all the data. Consider the grain size of the data that needs to be analyzed and visualized. Is it at a detailed level or an aggregate level? A key aspect of getting insight from your data is finding patterns. The right visualization will help you gain a deeper understanding of the patterns in your data in a much quicker time frame. Visualizations highlight one of the following 5 types of insights: key performance indicators, relationships between 2 variables, comparisons of variables, distributions of data, and compositions of elements that make up your data. As you consider the characteristics of your data, consider the volume, velocity, variety, veracity, and value of your data. How much data is there? At what speed and volume does it arrive? How frequently is it updated? How quickly is it processed? What type of data is it? Using the 5 V's as an overarching framework, consider what types of data you are dealing with. Historical analysis or streaming IoT data? Structured, semi-structured, or unstructured data? How will the data be visualized? In a periodic report or an interactive dashboard? For a fraud detection use case, consider the business needs first. For this purpose, 2 use cases are shown as examples here: rule-based fraud and machine learning in real time. Next, consider the characteristics of the data by asking questions. Rule-based fraud detection takes a reactive approach and provides a historical reporting of fraud cases. Structured data is ingested, analyzed, and reported in predefined intervals. In contrast, the ML fraud detection example takes a proactive approach. It provides the ability to detect fraud in real time as millions of transactions go through the streaming pipeline. Keep these questions about access to the data in mind as you select analysis and visualization tools. Where does the data come from? Will the data need to be combined from multiple sources? Who needs access to the data and at what level? Who can access the tools? Based on the principle of least privilege, a user's authorization to access data depends on their role in the organization. Consider this as you think about selecting tools and services to analyze and visualize data. For example, a business analyst or manager might be authorized to read the output that data engineers or data analysts create, but not delete or update it. An analyst could work with a data engineer to query data and be able to perform interactive analysis by using Amazon Athena. Domain experts and business analysts could ask questions and explore the data with a data analyst or data scientist to create a visualization by using QuickSight. A team might not include the roles with these specific titles shown on this slide, but someone on the team is likely performing the same functions. Here are a few key points to summarize this section. You learned about 3 factors to consider when you select tools to analyze and visualize data. For business needs, consider the granularity and format of the insight. For data characteristics, consider the volume, velocity, variety, veracity, and value of your data. For access to data, consider the functions of individuals who will access, analyze,